All right, let's dive in. Today, we're talking about a really fundamental shift in tech. It's about how we can take our cloud operations from this constant, manual, reactive firefighting mode and turn them into a fully automated, proactive system. Really, this is the journey from just using the cloud to making the cloud truly work for us.
But let's start with a big, kind of mind-bending question. What if your cloud infrastructure wasn't this thing you had to constantly babysit, patch, and repair? I mean, what if it could actually anticipate problems, heal itself from failures, and enforce its own security rules, all without a human touching a keyboard? Now, that might sound like science fiction, but it's the ultimate goal of operational autonomy, and we're going to break down exactly how we're getting there.
So here's the plan. First, we'll hit the why, the absolute mandate for automation. Then we'll get into codifying your cloud, building out what I call the automated assembly line, learn how to release new stuff with confidence, and finally, we'll look ahead to the dawn of true autonomy.
Okay, first up, the automation mandate. Let's really get into why this whole shift isn't just some cool trend, but an absolute strategic necessity. Before we go any further, let's get our terms straight, because people use these interchangeably and they're not the same thing. Automation is tactical. It's making one specific task run on its own, like patching a server. Simple. Orchestration, that's strategic. That's the real magic. It's what coordinates all those little automated tasks into one big cohesive workflow, like deploying an entire application from scratch. And that distinction is critical, because real power doesn't come from automating tasks, it comes from orchestrating them.
So why do we orchestrate? Well, the business reasons are pretty obvious when you think about it. First, agility. You move faster. Automation just accelerates everything, letting you get new features out the door quicker and way more reliably. Second, cost. I mean, you reduce the need for manual work, for sure, but maybe more importantly, you get this super tight control over your resource use, which stops you from over-provisioning and wasting a ton of money. And third, scale. Your infrastructure can just breathe. It can grow or shrink on its own to meet demand, which means you're always performing well for your users.
But, and there's always a but, there's a catch. It's called the automation cost paradox. Yeah, you save money on manual labor up front, but the complexity of all your automated systems can start to creep up. And if you're not careful, without strong financial governance, what we call FinOps, your cloud bills can quietly go through the roof. The takeaway here is simple. Automation has to be paired with automated financial tracking. You got to protect that return on investment.
Okay, so now we get the why. Let's get into the how. To get to this level of automation, you need a rock-solid foundation. And that foundation is built on code. It's all about treating your infrastructure and your policies with the same discipline you treat your application code.
The first big pillar here is infrastructure as code, or IAC. And this is a total game changer. Instead of some engineer clicking around in a web console to set up servers and networks, you define everything in code files. You just describe the state you want your infrastructure to be in, and the tools make it reality. This is huge because it kills configuration drift, that slow, dangerous process where your environments get out of sync. With IAC, you get perfect consistency every single time.
Now, when you get into IAC, you find there's this big philosophical split on how to do it. On one side, you've got tools like Terraform. They use what's called a domain-specific language, or DSL. It's a language built just for describing infrastructure. On the other side, you've got tools like Pulumi, which let you use the same programming languages your developers already know and love, like Python or Go. And this choice, believe me, has massive implications down the road.
So let's break that down. With Terraform's special language, HCL, you get this really mature, robust ecosystem. But testing your code often requires extra tools, and you have to be really diligent about managing your secret keys. Now contrast that with Pulumi's approach. Because it's just code, you can use standard testing frameworks, and it encrypts your secrets by default, which is a huge security win. And then, of course, you have the native cloud tools like AWS CloudFormation, which give you deep integration but can lock you into one vendor. So the choice isn't just about syntax, it's about a bigger strategy. Do you want a specialized language for ops, or do you want to bring infrastructure management fully into your developer's world?
All right, the second pillar is policy as code, or PAC. Now, if IAC is the blueprint for your building, PAC is the automated building inspector. It's how you write down all your organization's security and compliance rules as code. This little automated inspector checks every single deployment to make sure it's up to code, right from the very beginning.
So we've got our infrastructure as code, our policies as code. Awesome. Now, let's see how this all plugs into the modern software factory, that automated assembly line that takes a developer's idea and turns it into a running system in production.
We hear the term CI/CD thrown around all the time, but it's really important to know the difference between the two types of CD. With continuous delivery, every code change is automatically built, tested, and prepped for release. It's always ready to go, but a human has to make the final call and push the deploy button. Continuous deployment takes it one step further. If all the automated checks pass, that code goes straight to production. No button, no human. That final manual gate is the key difference.
So the whole flow starts with continuous integration. Code gets merged, the system builds it. But the absolute linchpin, the most important part of this whole thing, is that middle step, continuous testing, or CT. And I'm not talking about just a few basic tests. This is a massive suite of automated security scans, performance tests, integration tests, all of it. It's constantly giving you feedback on business risk. Because without strong continuous testing, a fast pipeline is just a fast way to ship broken code. Only after passing all those tests does it move on.
And how do we enforce this? We use automated quality gates. These are basically checkpoints in the pipeline that code must pass to continue. They are not suggestions, they're hard requirements. A quality gate checks for things like, is there enough test coverage? Are there any new critical bugs? Did we introduce any security holes? And this is where it all comes full circle. It also runs our policy as code checks. A compliance violation is treated exactly the same as a software bug. It fails the build, and it has to be fixed. Period.
Okay, so our pipeline is fast, it's secure, we're building and testing code at an incredible rate. But now comes the moment of truth. How do we actually push these updates to our users without breaking everything? This is where advanced deployment strategies come into play.
And this quote just nails it. The whole point is to mitigate risk. You know, in the old days, deployments were these high-stress, all-or-nothing events. In this new world, they're controlled, low-risk, routine operations. The goal is zero downtime, and if something does go wrong, you can recover instantly.
Two of the most powerful strategies are blue-green and canary. With blue-green, you run two identical production environments. You deploy the new code to the inactive green one, test it, and then flip a switch to send all traffic over. Rollback is instant, but the cost is high. You're literally doubling your infrastructure. With a canary deployment, you release the new version to just a tiny fraction of your users. If it looks good, you gradually roll it out to more and more people. The critical thing to understand here is that this is a strategic trade-off. Blue-green is for those huge critical updates where you need absolute stability. Canary is perfect for iterative features where you want to limit the blast radius and get real-world feedback.
These advanced deployment strategies are really the peak of controlled, safe releases. They let us react to problems in an instant. But what if we could move beyond just reacting? What if our systems could prevent issues from ever happening in the first place? This is where we make the leap from automation to true autonomy. This is the future, where our systems start managing themselves.
And this isn't some far-off sci-fi dream. Look at this number, 51%. Researchers at Alibaba actually deployed an AI-driven healing system in their data centers, and the result? It cut the downtime of failed servers by 51% compared to their old rule-based automation. That's the power you unlock when you move from reactive rules to predictive intelligence.
This new frontier has a name, AIOps, or AI for IT operations. It's all about applying machine learning to the insane amounts of data our systems generate. AIOps platforms don't just wait for an alarm to go off. They can detect tiny, subtle patterns in log files to predict a failure hours before it actually happens. When a problem does occur, they can perform automated root cause analysis, finding the source in seconds, a task that could take a human engineer hours. This is the brain of the autonomous cloud. It's what shifts operations from being reactive to being truly proactive and predictive.
So let's just quickly recap this whole journey. We started with why automation is a strategic mandate. Then we built our foundation with infrastructure and policy as code. We secured our delivery pipeline with continuous testing and released safely using advanced deployment strategies. And each of these steps builds on the last, leading us to that final frontier, AIOps, which is what evolves automation into real autonomy.
And that leaves us with one last big thought to chew on. As AI increasingly takes over managing the machines, what does that mean for us? What is the new role for human creativity and strategy in technology when the infrastructure itself can think? That's the question we're all going to have to answer. Thanks for watching.